Let's see if I can find it real quick. Try to make a nice little tight pack. Alright, so you're going to skip some of that stuff right now. Kind of. Not really. This is going to be important. We're going to take that. You're going to need it later. Some of the stuff. Remember, these are photons. They are particles that you are discerning the x, y, and d spin of, right? Well, I have, in general, most rank structures, it would be x. Now, any part of the military or something else would be its y function, and d would be its d value, right? So like anything that's a negative, x or y is something in here, d value or d direction is something that is in one way, shape, or form internally they have their own parties, and externally I have something in the Masons, right? And both of us have this general rank structure. If you do the math, we probability it will do fun things if you really know what you're looking at. But you have to realize this is an up, 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 down, down, up, and downtown type of situation. What you mean, Jordan? Well, if you measured that value and you found out to be true, that was X, and you found something was in that group model, right? Then the X and Y model would have percentageables like this. That the reason you keep hearing that there's a bunch of more of them like this than just this regular setup is because you're walking through a subset of standard models. First, up. Let's see if we can find her. Hmm, 85. We'll go 83% of the time, really.
If X is different from D 15% of the time, and D is different from Y 15% of the time, then X and Y can be different from each other only 15% plus 15% of the time, which is a maximum of 30%.
Where's my coolons?
If one of the marbles in each pair has red for its D parameter, then we can have any one of the following situations.
So you know how I run this model, and I usually like to talk about it like because of the original charge, this is the teacher teaching the student, right? Some teacher, student, and you might have coulomb charges where they are equal. You might have charges where they're different, in this case polar to each other realistically, not just coulombs. But in direction is, this kid is not quite as good. This kid is obviously not as good as the system. Now 12 coulombs usually would say the larger charge, so this is the original teacher, this is the student of the first teacher, right? We're going to say the series dropped down from the student's perspective instead of the student's perspective that might have a different charge, right? Because now we're measuring it and you're saying as a student that I don't believe that stuff is true. Well, you're negative 8 coulombs. And the truth of the matter that is very logarithmic. It's very analytical in the way that works. Now, it's not always a perfect science given which particle position I choose to measure in terms of the experiment. But if you go to check this, as long as this kitty cat is X or Y indetermination, that they would be 70% of the time, X is going to equal 75% of the time here. With the difference being, let's see if we can no muzzle, no muzzle. Well, how does that work, Basil? You tell me. So this gets way more complicated than that, but I just wanted to bring up that reference. This is a psychological thing as much as it is a mathematical thing. This is as much a physics thing as is in a practical engineering or organic chemistry experiment. And if you do the math, which there is quite a bit to it, this is what you're looking at. Anyways, catch you next one.